All right, I got my slides here. Is everyone seeing that?
Yep, rock and roll.
All right, so here we're going to go over the particular game that we've put together for you guys to modify and use for exercises and extensions. So roughly speaking, I'm going to very quickly show you the history of the game so that you can become familiar with the messy process that is any design process. And then I will go over, spend most of the time going over the rules, so you'll be familiar with them when you see them in code, which will hopefully look, nice and elegant. But rather than pretend that I somehow magically formed this out of whole cloth, this started off as, a messy whiteboard sketch of how are we going to model different transitions between populations, and what are the actions that will artificially move things between transitions versus mild move things. You see people can get bitten and then they become a carrier, and they can worsen and become symptomatic, and they can worsen more and become a zombie. And then you can firebomb them and they become safely dead, as opposed to just shooting them and they become infected dead, because that's how zombies work. And that was the early parts of this, for the purposes of both trying to get things straight in my head and making sure that the rest of the team agreed that this was a reasonable direction. And you can see some of the early actions. I hadn't quite figured out if the interventions the player would take would be one-time actions, technologies you researched, policies you enacted, physical structures you built, or messages you sent to the population, which are all things you can imagine modeling, and exactly what the topology would look like. But the question at this early stage was all about, is Joel going to be able to code this before the course starts? Because if not, then this isn't a good design. Are we going to be able, is this tractable for the machine learning we want to demonstrate? Because if not, it's not going to serve our purposes. Is this credibly how diseases propagate? Because if not, we're not doing a good job of showing you a realistic model being turned into a game. And is it actually going to teach the things we want to teach? Because there's a meta goal here. And so flailing around to the whiteboard enough to get an idea. And then the next thing I did was then start trying to turn this into a paper prototype. My favorite paper prototyping tool is PowerPoint, because it's not necessarily the best presentation tool, but it's a great prototyping tool because it's WYSIWYG. What you see is what you get. And it's on every computer, and you can drop stuff in and it will print exactly the way it looks. And it's hard to make anything look pretty. And so there's no pressure to make anything look pretty. And so you just get something working. So this was enough that I could sort of DM it like a Dungeon Master, like a role-playing game. So I could have other people say what they want to do, wave my hands and pretend I was adjudicating formal rules, and mark off what people were and what statuses in different locations. And had, see if the transition rules produce the kind of stuff we wanted as another iteration of the same previous questions. Then it had to actually work out rules. And so this was me paper prototyping, sadly alone in my basement, which is not at all sad, because it's my favorite thing to do, is sit alone in my basement and play test games. And this is sort of all about making sure that when I actually try to play the game and actually do it following rules rather than just waving my hands, that it really does work. So when I say 50% of people move into this building, so that's a little green building. You can tell because it's green and clearly a building. And I say 50% people move in. What does that exactly mean? What if there's 5 people here? How do they move in? What if 75% of people are supposed to go west and 75% are supposed to go south? What does that mean? Do 25% stay still? Do they split? I don't know. All these corner cases start falling out when you try to actually have rules. And also just making sure that there are credibly, at first glance, there's not just a single degenerate strategy or single path to victory, that there's real choices for the player. That, in this stage, make sure that you could credibly try to detect the threat and then respond versus proactively respond versus isolate the population so that later response will be easier or something like that. And also in general, this is just running through bits of the game against myself. There's no other people here. This is, in fact, my basement post-COVID. But it's also just polite to play things against yourself before you go and play them with other playtesters, because playtesters are volunteering their time to play a game that is not finished. And you want to be respectful of that by having done as much as you can against yourself, however weird and imperfect it is to run that simulation. So here I'm testing out the movement mechanics that I'll go over in a moment. And then the next thing I did was write up a written document that was meant to be as thorough and formal as I could be. Close to what you would put as a rule book in a board game, although not written the expository style of introducing somebody to the game, but trying to be thorough in exactly what happens on a turn and or everything happen in what order, and exactly what are the states that you can mean, and exactly how do things proceed when you don't intervene, and what does it mean to build a building? How do you express what a flu vaccine means on the system formally, so that, is the system expressive enough? And, things like that. And of course, as I did this, I found out that a bunch of the things that I could adjudicate against myself were really hard to write down, which meant they were either too complicated or not well thought out. And then I got this to a theoretically point, and then I passed it off to Joel, who then put it into code, and then found a few more cases where it wasn't quite formalized or was a little bit ambiguous, or where something that I thought was simple to say was actually quite complicated, either from a machine learning standpoint or just from a player understanding standpoint. And so what I'm going to show you is what's in the design spec, and then you'll be looking at later at what's in the code. And as I go through this, hopefully Joel will point out any places where what he put into code does not quite match what I thought I was putting into the design spec. Well, we think we're pretty much in sync here. But there's always a chance there's some discrepancy. And there's one place I know where my design spec has some stuff that we intentionally took out when we talked about it, because it turned out to be much messier than we thought it would be. So with the rules, of course, as I've been pushing all along, well, maybe I'll pause briefly because there's all these chat messages that are probably just B jokes, but let me see. Oh, formal questions about zombies. I'll answer all of your formal questions about zombies in a moment. That earlier model wasn't even quite the full model that I ended up using, but it was getting at this SERD model, which I guess you're going to get in a later lecture. When I first made this lecture, I thought maybe you already would have seen the one on disease propagation. But I'll talk about that a little bit when I get to the rules for that section. But yeah, and one of the things about this kind of a structure is, can you build it so that you can model different kinds of zombies, which is actually a pretty close analogy to modeling different kinds of biological infectious disease. The difference between a bacterial infection and a viral infection is shockingly similar to the difference between a viral zombie and a necromantic zombie in terms of their level of infection versus level of intention and things like that. But I won't digress on that yet. So let's go over the rules. So I'm going to start off, as I've been pushing in this course, and think about what do we want to do before we dive into talking about what it is. So analytically, we want to be able to identify the most effective strategies for saving population against these threats. There's zombie and there's flu, and there's a confusion between zombie and flu, and they're both representing a health threat to the population. And we want to know what we should do. So the mayor has asked you, what technology should I invest in, and how should the people be trained so that we will be ready when the zombies come? Because we assume that the zombies will come. And so there's the direct question of the strategies, and then the technology question of which capabilities enable those strategies or have to be compensated for by those strategies. There's also a second part of this of what is the biggest threat? Should you be primarily worried about the zombies or primarily worried about the flu? They're actually dangerous in different ways. As you'll see in the formal model, zombies are dangerous, of course, because you're much more likely to die from zombies than from flu. Flu is not that deadly, all said and done, even though my version of flu is pretty deadly as flus go. However, when somebody starts turning into a zombie, they're clearly a zombie and you know you have a zombie outbreak. When people are getting the flu, they can be incubating the flu for a long time before they manifest symptoms, and you don't even know you have a problem you should be treating. And so there's an immediacy of the problem versus a transparency or invisibility of the problem that makes it obvious which of these threats is more concerning and should have more of your resources dedicated. And we don't just want to answer this question once. We want to have a tool that lets us answer this. So if you say, well, we're worried about viral zombies, what's the right policy? Well, but this year we've had a breakout of necromantic zombies or bacterial zombies or parasitic zombies. And those have different characteristics. And we have different kinds of flus and bacteria that we're worried about being confounders. And so can we then quickly change the parameters and then still answer that question? So that's your programmatic goal. Now in-game, your player doesn't care about any of that stuff. Your player does not care about you learning anything. Your player wants to win. Your goal is to maximize your score by the end of the game. If you remember from my earlier lecture about how you deal with multiple objectives, in this case, I've done a weighted sum, because that's the simplest thing to explain to a player. It might be interesting as an extension to enrich this or look at other analyses you could do if you change this, but for now we have a weighted sum. So everyone who's active, so active, I'll define it formally later, is actively a member of society. You're not sick in bed. You're not curled up waiting to turn into a zombie, and you're not a zombie, and you're not dead. it gives you full points. And if you're sick but still alive, you get half points. If you're zombie, you lose a lot of points because that represents an imminent danger to society. If you're dead, you score nothing. So dead is worse than being sick, but better than being a zombie in this game. And there's also some notion of fear, which reduces your overall score. Fear in this game is fear the general populations has of you as the authority responding. So if you firebomb the zombies, the people get scared because you're firebombing them, and then they don't behave as well. They don't listen to you and trust you and tell you things. And you have to value information versus boldness of action. And maybe you shouldn't firebomb quite so many neighborhoods just to get the zombies. But then maybe that saves more lives than it's worth. That's the kind of question we want to answer here. Now, related to this, we hope to come out of this is something about how do humans perform versus machines? Is this a problem that the machines can just nail for us? Or is this a problem when the machines get hung up because the state space is too big and you need humans to warm start them? Or maybe you want the machine advising the human on some strategies, but humans polish it, or the humans figure out a strategy and the machines optimize it? Or is it really just only amenable to one or the other? It's not obvious offhand. We can formalize this, but that's not the same as knowing how it should be solved. Are they teaming together, or are we picking one or the other? Or are we just picking which machine learning method is best? I mean, there's hundreds and thousands of machine learning methods depending on how you count. And so those are going to be side effects that we ask, but ultimately we only ask these questions in order to get at this analytical goal, and the player just wants to win. Okay, so here's what the game would look like in my spec. For expediency and for leaving interesting UI questions open to you as the possible extender, the actual game is a pure text interface, although Joel has done quite a good job of making the text shockingly spatial. But abstractly, the player is going to see the city. Right now, the city is a 3x3 grid. You can't move diagonally. In every location, there might be some buildings. In the code, they're actually called deployments, which is actually a better word than building. I fell into the trope of video games and board games where everything you build that has a special power is called a building, even though these are more abstractly a team of specialists that have been deployed to that location. Not necessarily a physical structure, but I'll call them buildings for convenience.
Also, Rob?
Yes.
Sorry. So when you view the game state currently, the interface for the game does not show which buildings are in what neighborhood.
Yes, although it's perfectly reproducible from your history. So if you take notes, you'll never have mysteries about where the buildings are. But yeah, right now the interface is clunky but functional, and that's often where a research tool is when you start doing studies with it. And one of the practical questions is, how nice do you need to make it to get the data you need? It might be ugly and clunky, but it's enough to get the data, and then you move on with your life. And it might be you're getting noise from your users or deceptive results because nobody understands it, and you better polish that interface. Or if you're leaving it behind with somebody who's going to use it without you, it had better have good tutorials and intuitive interface. So right now we erred on the side of clunkiness, partly out of expedience and partly out of leaving options for you to expand on. So you can see the buildings that you've built in the past here. You can know those. You can see the census, which is how many people were there at the beginning of the game. You know perfectly where the world started. In this city, there's about 100 people. We debated different scales. You could consider maybe one person is abstractly representing 1,000. Doesn't matter in terms of this model, as long as you're clear on what the abstraction is. And you have these categories of people who are active, sickly, zombie, or dead. So active is moving around and healthy. Sickly is not so great. Zombie is violent and homicidal and trying to bite people and turn them into zombies. And dead is dead. Never going to become one of those other states. Well, never going to come one of those states again, but I suppose sometimes the dead rise into zombies depending on the kind of zombie. Now, part of the twist here, which was partly done to manage the size of the state space to make this more amenable to learning, and partly done because it is a realistic model of real decision-making, is that you don't have perfect information about the current state of the world. You don't know exactly how many people are healthy in an area and how many zombies there are in an area. You get these ranges. Things either say none, few, or many, or maybe they can say all. I can't remember if that's even an option. I think it's not formally an option. You could add that. And those are ranges. And so you have a rough idea about how dangerous the threat is in an area. And furthermore, the more people get scared of you, the more your fear goes up as a result of taking drastic, desperate action or panicking the population, the worse your information gets. The more likely they're just not going to report that they see a zombie, because the last time they reported a zombie, you firebombed that neighborhood. And they don't really want that to happen. They'd rather fight the zombie. And so there's some formalism here, but roughly speaking, if you scare people, you get worse information, and you've got to make that trade-off. There's also a notion of resources, which is your ability to respond after the incident starts. So presumably you are deciding what equipment you have on hand, but it still is expensive to deploy that equipment, and you don't have enough manpower or whatever other constraint you have to deploy everything. And sometimes some things will consume resources. So if you set up a facility that consumes a lot of medical materials, it may use resources every turn, and you need to have something that provides those resources, or you're going to bottom out. But this is what you see. You see just the status in every rough status in every location, where everything started, and what interventions you've taken, and then these global options. You also see what turn you're on. And right now the game is played over 14 turns, and the idea is that every turn is about a day. And your question is, how healthy can you make this city at the end of 2 weeks? And
I think there's some questions in this chat.
This is a good time to pause. All right, I have to rediscover chat. All right, here we are. Okay, how many types of zombies are there? Right, there's one type of zombie at a time in the current game, but there's going to be parameters that are easy to adjust that will change the character of that zombie. There's actually rules for the zombies, rules for the flu, and rules for society as a whole. And you can change those. It is definitely possible to get a negative score. There is no bound on this. And this is actually a perfect example where some machine play will probably help improve this scoring rule. I don't know if that's the right scoring rule to produce the realistic pressures. It's credible in the sense that charging full value for healthy people and half value for sick people is a pretty good heuristic, probably going to get you in the right track. But I don't know if fear should be -1 point per 1 point of fear, or if that's going to make you fear obsessed and only ever keep the population happy, but mostly zombies, or if that's undervaluing it and you're just going to completely ignore it, or if it's an interesting middle ground where you really have to build in a mental model of how to judge those things. And similarly, I don't know if I'm undervaluing the sickly or not. Maybe maybe the optimal strategy is to just worry about zombies and ignore the sickly. Now, if that turns out to be the case, that could be a mistake in the game because we are giving the wrong incentive and therefore not producing credible behavior. Or that could be, as we discussed earlier, a lesson that you learn. Maybe the real lesson is, don't worry about the flu, you've got freaking zombies. And so you're gonna have to make a judgment when you either get an optimal strategy or a degenerate strategy, if that's credible or not. And that's fundamentally a qualitative call by you or by domain experts that you'd be interviewing if this were a real problem. There is always a fundamental informal link between the formal system you build and the informal things you want to accomplish in the real world. And that link can be made systematic and it can be made accurate, but it can never be made perfect or formal. And much of scientific and engineering judgment is managing that link as much as it is about cranking the model once you have the model. Let's see. It would be kind of fun to add multiple kinds of zombies at once.
So Rob, there's a question. Are there ways to lower the fear meter?
Yeah, they're appearing about as quickly as I answer them, so we're never going to get off this slide.
Well, if you want, I can read you the question.
No, it's fine. Can you lower the fear meter? Yes, there is actually a kind of building. There are actually a couple of buildings that will lower the fear meter, and I'll get to those. I think there's one that's public messaging that's main goal is just to lower the fear meter. There's also one that has a main goal of attracting zombies. You can produce meat-smelling pheromones in a location, which will draw zombies into the location, which might then concentrate them and allow you to deal with them. But it also turns out that I'm making a bold claim that people like the smell of meat, and therefore it will calm the people down. They will be less fearful when they're smelling meat, which maybe is opposite. I mean, that might need to be something you validate in the real world, but I'm claiming that evolutionarily people like meat, whether or not they eat meat in the modern day. But you can model those things. If you think that assumption is wrong, I've got parameters exposed that you can use to fix it. I put in my best model of the technology and of society, and then see the consequences. And then part of your job in looking at this is, where do you think my model is poor versus where do you think you can build a better extension on top of the game to learn something about the model if you think the model is credible. So you start with 0 buildings and a mostly healthy population. We will seed a few threats in the population. One of the things we have not done here that'd be really cool to do and be best practice would be randomly change the seeding values, where sometimes there's just zombies, sometimes there's just flu. Right now, there's always a little bit of zombie and always a little bit of flu, both of which will spread if untreated. And they're in random locations, so you can't game the system too much by just always firebombing the northeast quadrant and then killing the one zombie and then moving on with your life. Well, moving on with 8/9 of your lives. So there's enough procedural variation that you can't completely cheat, but not as much as I would like. Yeah, can you move people? One of the models is about how people move on their own. One of the things you learn when you study emergency response is, boy, can you not tell people what to do. And this is true in democracies, and it's true in authoritarian regimes. Boy, during an emergency, people will do what they feel like. If you announce an evacuation and you get 40% to listen to you, you're not doing so bad in a lot of cases. It's unheard of to say get 90% of people to listen to you when you send out a message that's for their own good from an expert. So some of the buildings will affect the flow of people in an indirect way. Can zombies carry flu? Well, we'll get to that, actually, the model. And are zombies immune to flu? That's an important question, which actually I struggled with for a while, because in a lot of versions of zombieism, the zombie virus is a jealous virus and kills everything else in the system. On its way to then taking control of the host, because it doesn't want to host. I guess the reason is it doesn't want to host that's all sick, but then it lets the host rot. So it's possible zombie movies are not entirely internally consistent and cross-consistent. But anyway, in this version, zombies your zombie status and your flu status are independent, which I'll show you in the formal model in a moment. And therefore, the consequence is that, yes, zombies can give flu to people, which occurs to me probably shouldn't be the case. We should probably clarify the rule that says your chance of getting flu is proportional to the number of people with flu to the number of people with flu who are not clearly zombies, because you're not getting close enough for them to cough on you. But I don't know how significant that shortfall is, but I think that's probably a hole in the model. So the main goal analytically is, what should your strategy, what building should you build, in what combination and in what order, in order to maximize your health score at the end of 14 turns. So should you build a bunch of pheromones and a bunch of sniper towers and try to draw the zombies in and shoot them in the head? Should you build a bunch of bite centers and a bunch of flu vaccines and try to just immunize the public? Should you build a bunch of fences, or should you try to move the population dynamically in response to the threat as it emerges? Unclear. Yeah. So Afi, my assumption is that my assumption that is built in the model, which you can adjust if you think it is wrong, is that meat smells good evolutionarily, and that vegetarians should not be offended by this. They should consider that makes them even better vegetarians if they don't eat meat, even though meat genetically smells good to people. And my claim is that the zombies are not vegetarian, to Yavitsky's point. These are zombies who want to bite people. In fact, my model involves they sometimes bite you and let you turn into a zombie, and they sometimes bite you and eat your brain, and then you don't turn into a zombie because your brain has been destroyed. Yeah. Do dead contain both zombies and dead flu patients? So we'll get to that state model in a moment. Yeah, if you die, you're dead, but I actually have two notions of dead and rotting, and dead and ashen. The ashen people are really, really dead, and the rotting people still might have a negative effect on society by lowering public health or by turning into zombies. And that's another thing you have to adjust based on your zombie model. Necromantic zombies, all dead raise as zombies because there's a necromancer casting a spell on them. But when they bite you, they don't necessarily turn you into a zombie. Whereas viral zombies, you have to have the zombie virus in you to turn into a zombie. So if you die of something else, you shouldn't turn into a zombie. Unless it's airborne, in which case everyone's infected and just hasn't turned you yet. So this is some of the subtleties that you actually want to get at, which is there one true policy for all zombies that is an 80% solution for every zombie strain? Or do you need a very different contingency plan for different zombie paths? And this is exactly the question people ask in real public health, is should we have a different contingency plan for a smallpox outbreak or a virulent a bacterial anthrax outbreak or a fungal outbreak or something else. And that's the kind of questions we want to study here.
Do all flu patients turn into zombies?
Yeah, so we'll get there. Right now, that's independent states. Yeah, I agree that the desire for zombies to eat brains and the fact that you destroy a zombie's brain to really kill them does seem like an odd contradiction, and it makes you wonder about these scenes where people get ripped apart by the zombies. Like, that's not in the virus's best interest. They should bite you, and as soon as you're bitten, suddenly stop eating you, and you think, oh wow, I got away, and then you turn into a zombie and bite 3 more people. But nobody says that the virus is perfectly optimal. The question is, can we model what the effect of this is? So I'm going to go back to going through this because I think we're getting into questions that are the next one. So your statuses are tracked in by the individual. So every individual actually has their status tracked. And therefore, the rules are being propagated on individual sector region, but fear and resources are global. The entire city fears you or doesn't fear you. If you firebomb one neighborhood or start using experimental drugs that have not been approved by the FDA, you get a fear penalty globally. Everyone hears about it. But you have to then deploy it in a building, which then gives you a local benefit. But we'll get there. So this is what the player sees. Now let's look at what the player does. The thing that a player does, oh, in fact, yeah, answering questions that were asked. Well, you're ahead of the game. You start with, yeah, these things I talked about. And you start with, yeah, I think 10 resources and a little fear. And naturally, the resources slowly go up. Society produces stuff naturally, and fear slowly goes down. People acclimate to the horrors of the zombie apocalypse over time. But that's going to be a drop in the bucket compared to the consumption of resources you might want on some strategies and the level of fear that can be generated by some side effects. So every turn, you place 2 buildings. There are 24 buildings, technically. Actually, there's 12 buildings, but each has 2 flavors, and functionally, that's exactly the same as there being 24 different buildings in this version of the game. And every turn, you put 2 of them each into any location. And that is your action. You see what the state of the world, you drop buildings in, you update the state, and then you go to the next turn. Now, buildings have a name, which is a thematic clue as to what it's going to do, but doesn't mean anything. They can add state transitions, like they might add a treatment to a disease that does not naturally cure itself. They can modify transitions, like they might lower the rate of a transmission. They might give you or take away resources. They might give or take away fear. They might make people move in different ways, either by giving them a bias towards moving in a certain way, or by blocking them, like there's a fence, they might get blocked from entering a certain area. And sometimes a building has a one-time effect when you first create it. Like I think when you do a celebrity endorsement of social distancing, there's a one-time fear effect because, oh my goodness, even my favorite movie star says this. But once you've heard one movie star say it, it's not as impactful when you hear them say it more and more. But when a second movie star says it, it actually, you notice again, whoa, they care about it too. Versus some buildings that every turn of the game make you scared just because you have a limb amputation facility that is removing bitten limbs from people, which is kind of scary, but maybe good for the popular health. So we try to model these different effects. And as I mentioned earlier, this game went through a number of series of expansion and contraction. And this is a result of a bunch of those where I added stuff that it seemed like it enriched the model. And then I took away stuff that seemed like it was just a bridge too far and too much and unnecessary. Some buildings, as their resource impact says -1 resource, they're also all flagged as an upkeep building. If you run out of resources and you can't pay your bills, all of your buildings that need upkeep are immediately destroyed, which is usually bad because you spent a lot of turns and invested a lot of game tempo in building them. But it could be good if they're having side effects that you want to have go away. Not clear. Logically, I have paired the buildings into a nice and a severe version of each building. So when there's a flu vaccine, there is a flu vaccine, and there's an experimental, not as safe but more effective flu vaccine. And when there's a bite treatment center, there's a mild bite treat center, and there's a martial law imposed bite treatment center. And generally, the nice one has a mild effect but no side effects, and the severe one is much more effective and has a nasty side effect. And one of the big questions in the game is how severe should your response be given the side quest, and when is the the cure worse than the disease, and when is it just necessary to make hard choices. I will pause for questions before I go to the state machine. Yeah, so in the current setup, which is not very randomized, there's a graveyard with 10 dead people, which is relevant because dead people do affect public health locally. And so like you might want to build a kiln in the first turn and start incinerating the dead people. Or you might say that's a pretty low priority because I have bigger concerns like the zombie who's actually biting people. Okay, so let's go to the state machine because a lot of these are getting at this formalism. So here is the state machine. Now, this is based on the SGAI model, which means susceptible, exposed, infectious, resilient, dead, which are roughly speaking the states you can be in with respect to any disease. Susceptible means you could get sick but are not sick. Exposed means you have gotten infected, but you are not yet showing symptoms, and in most diseases, you are not yet infectious. One of the things that's so difficult about COVID is that you are infectious during the incubating period before you show symptoms. And this varies in other diseases, but you're sort of doomed to eventually get sick when you're exposed, but you can't, it's very hard to detect. By normal, a doctor's visit, no one can tell that you're sick, although there are some modern physiological sensors that have a chance of doing this, and that's some stuff that I know some people in research labs have studied recently, but by default, you can't tell. Infectious means you are visibly sick and coughing and therefore can get other people sick at a high rate. Recovered, which means you have no longer gotten sick. So if you're a virus, if you're dealing with a virus and you recover from the virus, you are now immune to that virus. You can imagine modeling, in fact, I have a little thing in the model we'll get to in a moment, where a virus could mutate and then you're no longer immune to it, but that's a separate transition. That means you've gone from resilient to susceptible. But when you're in the resilient state, you're immune to that virus. Now, with most bacterial infections, if you survive the bacterial infection, you're just as vulnerable to getting it again. If you take antibiotics and wipe out some bacterial pneumonia you've got, you can get the same bacterial pneumonia again if it gets in your body. It's a little organism that's growing, whereas viruses, your body has learned how to defeat. Now, in our state, there is no R for zombies. If you recover from being a zombie somehow, you go back to being susceptible. And if you get bitten again, you're in trouble.
Rob, before we move on, sorry.
Yeah, so that's the SGAI model. And that's and sometimes people just do SIRD, they leave out the E. Sometimes they do SEED and leave out the R. Depends on the disease you're modeling. But those, roughly speaking, are the states for one disease. And then you have those states for each disease. And most diseases are independent of each other. So you have a status, you have a zombie status, and you also, independent of that, have a flu status. And you also, independent of that, are either dead or not. So let me pause before I ramble on more.
I'm just going to say that the names of these states in the code are slightly different, and each of the states are separated out. So for example, the zombie, the states are human, zombie, bitten, and zombie.
Yeah.
Instead of non-zombie.
There's sort of three notations here, and there's what's written in the code, which is pretty close to what's in the spec, which are these things on the left, which then map to this standard model, but not what I used, because those letters, there are a lot of I's in disease management, and so I is not a good variable name. You can be incubating, you could be infectious, you could be infected, you could be immune, and so I've gone with this notation shorthand, which will be, I think, written out in longer form in the code of you're not a zombie, you're zombie bitten, or you're a zombie. You don't have the flu, or you're flu bitten, which I used to draw the clear parallel with zombie bitten, you're incubating or you're exposed. You have the flu and are now symptomatic invisibly, or you're flu immune. You can get immune to flu, you can't get zombie immune. You can imagine extending the game and ask, does it matter if people can get zombie immune, or is that a minor detail because they're also eating you? And then you're technically either dead, dead ashen, or not dead. Now, in the simple version, with no optimization or simplification, there are therefore 3 times 4 times 3 states you can be in. You can have any of these 3 states, any of these 4 states, and any of these 3 states. Now, as we were talking before, if you want to say that the zombie virus exterminates the flu, then zombie bitten should push the person back into non-flu, or maybe even flu immune. I don't know exactly. Pushes you in one of those states depending on where you are. But it doesn't do that in the game. Right now, these are independent. It also means that if you're dead and ashen, which is really, really, truly dead, you also technically still have a flu status and a zombie status, which will never matter in the game. But
it'll still count towards the totals.
But yeah, I mean, it depends on, yeah, I mean, and you have to think about that. So if you're dead, you shouldn't be infecting people with flu, although it's possible that's how it's implemented, and we should think about what the way it should be implemented is. But that's the way it's expressed. So it's expressed as what is called a cross product. So the state space for any given person is one of these statuses and one of these statuses and one of these statuses with all combinations possible. And mathematicians who are lazy and like to overload terms use the X as the cross product symbol between sets. So there's a set of your statuses, cross product, your set of your statuses, cross product, your set of your statuses, because that reminds you of multiplication. And the total number of states is the size of this set times the size of this set times the size of this set. And no one has ever been confused by mathematical notation, and certainly won't start now. But that's the state. Now, obviously, you know, you can consider if this is a mistake. It might be that somewhere in the code it's checking the number of flu people, and I, as the designer, may have intended it to be the number of living flu, but I just wrote flu, and Joel probably authentically wrote down my spec, and maybe I'm counting dead flu or dead ashen flu, and those shouldn't be counted because a pile of ash doesn't have a virus anymore. That's a question for the studious researcher to inspect and possibly modify. But that's
Rob,
the model we have.
Yep.
Right
We
now,
have
it's
some-
mostly a declarative description of where we are. Sorry, Joel. Go ahead, Joel.
I was just gonna say we have some questions building up.
Yeah. I'll just
So I
briefly
can-
say, there's
right.
also these group terms that I just use as shorthand. So like active means you're actively moving around, which means you are not bitten by a zombie and curled up in the corner, and you are not symptomatic of the flu, but you might be incubating the flu or completely non-flu or completely non-zombie. You're an active member of society. Zombies are not active because they're not an active member of society. Sickly are people who look sick. So they're bitten by zombies or they're symptomatic. And one of the twists in this game is you can't tell the difference between someone who's been bitten by a zombie and somebody who has symptomatic flu. They both look kind of sickly, they're coughing, and they definitely won't show you their bite because I saw what happened when you do that. Now you can take interventions that might distinguish those cases, but that's one of the confounding factors, and this is true of real public health. Is the biggest problem in public health is possibly the fact that every disease ever has flu-like symptoms. What's the symptoms of all of the nasty diseases that everyone really worries about terrorists using? Flu-like symptoms. What's the disease of the common cold? Flu-like symptoms. Great. So a bunch of people in my city have flu-like symptoms. Should I be worried? No idea. That's why there's science to be done. All right. Questions?
So I think the first one is, can the virus mutate?
Yes, I will show you that when I get to the state transition model. This virus, as coded right now, has an extremely low mutation rate. But that would be an obvious thing to shift, is does the mutation rate fundamentally change how you treat the disease? Or are you not, like, are you essentially relying on people becoming flu immune in order to get herd immunity to protect your population? Or are you trying to actually cure them or prevent them from getting sick in the first place? And in one of those cases, you'd expect that a rapidly mutating virus would matter. And in another case, you would think it wouldn't matter at all. And so that's some of the real questions that people ask when they're asking about technology. So you have this device that can, you have this method that can prevent the spread of the disease. Is that worth deploying, or is that only going to delay the inevitable? And what I really need is something that helps people recover more quickly. Or is it vice versa? Once they're already sick, it's too late, and recovering more quickly is a drop in the bucket. And that's the kind of analysis that people really want to do with this kind of analysis. This is actually an extremely realistic game for the kind of a game you would build for this kind of public health analysis. It just happens to have zombies in it.
Rob, so the rest of the questions are about like the transition probabilities.
Yeah, so we'll go to the
stuff,
transitions
so.
then. So these are the universal laws, or these are the natural laws that are present all the time. So if you never intervene and do anything in the game, this is how society will progress. And I've lumped them into things that are always true, things that are about flu, and things that are about zombies. So And then there's a parameter for every one of these to make it really easy to change this rate. So the way you read this is everything is modeled as an individual. And these things might then later be modified by buildings you build or things that you do. Or you might go in and say, well, what happens if your recovery rate is only 5%? And you'll change that. But everything is handled at an individual person level. You could also do what's called a population model, where you say 5% of the population who is sick recovers each turn. Or you can say each person who is sick has a 5% chance of recovering each turn. And in aggregate, those are going to work out to be roughly the same, but they are very different in terms of how easy it is to express different kinds of modifications. And we found in this case, I originally started with the population transition model, and it got really messy really quick. When you say 50% in this location move west and 50% move south, what does that mean? Does that mean 25% move southwest, 25% move west, 75% move south, and 25% stay still? Or does it mean 50% go west and 50% go south? What does it mean if there's two 50%? And what if there's two 75%? And those can all be resolved, but it got really messy. And so I went to the individual population model because it was much easier and cleaner to describe the transitions. But of course, it's computationally more intense. If you want to have 1 million people, you have to do this calculation 1 million times. Whereas in a transition model, if you want to have 1 million people, it's still just multiply that number by 0.05. So population models scale really well, but they lose some expressiveness and they get very messy quickly with certain kinds of interventions. So let's look at some of these rules. So burial says, if you're dead, you might become dead ashen, which is to say, you might stop being a rotting corpse that can potentially harm the health of society and basically be absent. That could be because you rot or because people naturally bury you. In this case, it's because people naturally bury you in the ground. When there are dead people, we tend to put them into the ground or we cremate them, but humans intervene. And so the chance of this happening is based on the number of active people in that location times some constant. A more direct one that isn't as complicated would be, say, what's the chance? If you have flu, you might become flu immune. And I just say every day, 25% of people who have the flu recover and are now immune. And 1% of people who have the flu die of pneumonia. And of the people who are flu bitten, that is infected by flu but not yet showing symptoms, have a chance that they will start showing symptoms. In this case, 25%. Now, this is still a probabilistic transition model. You could imagine me actually tracking the number of days that you have been sick and raising the probability that you will show those symptoms based on the duration. That would be a more complicated model that would probably be more realistic depending on the thing you're modeling. But probability transition models turn out to be pretty good at getting the same effects as sort of historical individual tracing models, even though they're obviously a little bit less realistic. The results are very similar. And so that's what we're using right now. If you don't have the flu, you have a chance that you might get the flu from fumes of dead bodies. In this case, it's every dead body in the area gives everybody who doesn't have the flu a 1% chance of getting the flu. That's actually not usually how viruses work. That's more of a bacterial thing, but some viruses can survive in dead bodies for quite a long time, especially if the environment is cold. There have been concerns when people dug up bodies from the smallpox outbreak that had been buried for a couple of years, and they're very worried that there might be smallpox alive inside of them because cold preserves viruses. So, we put this in. You can adjust that number accordingly. There's also, of course, coughing, which is the chance that a non-flu person will become flu-bitten, that is, be infected but not yet symptomatic, is proportional to the number of people who have flu in the area as a percentage of the total population that you interact with. So if there are 1 person in the population who has flu, and there are 10 people who are walking around, in this model, I'm saying you bump into all of them with an equal probability, and therefore, every day you bump into 1 person at random, and if they have the flu, you get the flu. So that's what this model says. You could scale that up or down if the chance of bumping into somebody gives you a lower chance of getting a flu, given that you bump into them. But the idea is that there's 9 people with the flu, and of the 10 people who are moving around, then there's a 9 out of 10 chance that you will get the flu, because the 1 person you bump into each day is much more likely to cough on you and have the flu. there's some similar logic going up into the burial, which is based on the more people there are in the area, the more likely any given dead body is to be buried. But if there's more dead bodies, the lower the chance of any one dead body to be buried. And if you work out some examples, you'll see this falls out very cleanly. Here's the mutation factor, which says if you are flu immune, there is a chance that your immunity is no longer valid and you are not flu immune anymore. I have that at 1% per turn, very low for a short scenario like this, but you could adjust that and see what happens. There's a question here about should you model the flu as mutating or model the person as losing immunity? It's subtle. So like if you play the computer game Plague Inc., where you play as the virus trying to wipe out humanity, which actually the CDC has officially sanctioned as an extremely instructive game about disease propagation, the main unrealistic thing they have is that when you mutate your virus, every instance of that virus everywhere in the world mutates. And that's not how viruses work. One virus somewhere mutates, and now all the other people who are immune are no longer immune, and that virus has to spread again. So this is actually a better model, which is to say you're flu immune, but does the flu you bump into a strain that is too far in the past to still be relevant for your immunity? Did you get what's the least common ancestor between the flu you're immune to and the flu you're exposed to? And that's really an individual person level. And in fact, if a virus mutates and you are immune to an old version, you still have partial immunity. The flu vaccine every year is only partially effective against the current flu, but if you had the flu vaccine the previous year, you actually have partial immunity and reduced symptoms from the next year's flu, even if you don't get the next year's flu vaccine. So this is actually a pretty good model of mutation. And then we have similar things with zombies. So let's look at how zombies work. Now, actually, before I'll say, I put these in a very careful order because this is also order that the rules adjudicate in. When we run the game, we first see if you recover, then we see if you die. You get a chance to recover before you get a chance to die. Then we see if you worsen, which happens before. You can't go from flu bitten to flu and then die all in one turn. There'll be at least a turn delay because we check the death before we check the worsening. And you have to decide if that is the right direction, right sequence or not. It seemed like it was a better model now to add a certain amount of time delay in the model. Yeah, someone's asking about if you start immune. That would be an interesting capability. You could ask if 50% of my population starts off immune, if I said had an effective a vaccine or partially effective vaccine, does that change not just my health outcomes, because obviously it'll make my health outcomes better, but does it change the strategy? Which is an interesting question, because it may be that if half your people are immune, you still do exactly the same strategy, you just get a better score. And it might be you use an entirely different strategy because the game is now very different, given that there's much more herd immunity. And that's a question that is not at all obvious until you start building a model and really study it. And that's why we build in, the initial conditions are highly parameterized and the transition rates are highly parameterized and the effects of buildings are highly parameterized. So you can study those kind of scientific questions. You can study it as a model. You just run this in isolation, forget all the player, forget the AI and the human, and just run the model and ask which of these factors is most problematic to a society. And then you can start adding in these factors of, well, there's this rich reaction space that's hard to model. Let me modify the game and see what the best players do or what the best AI does to try to study. Okay, so zombies work a lot like flu. You might turn into a zombie if you're zombie bitten. So that means you have a bite on your arm, but you're still thinking and acting like a human, but it's in your system and you are doomed to eventually become a zombie. 20% chance every turn. Not good to be bitten by a zombie. Also, if you are not a zombie, but you run into a zombie, you might die. That's when they tear you open and eat your brain. So that is, once again, number of zombies divided by number of moving times 0.5. So you bump into a random person every day. There's a Z over moving chance that that person was a zombie. And if they do, there's a 50% chance they eat your brain, and then you're dead. The other rule is actually very symmetric, which is there's a 50% chance that instead of eating your brain, they bite you and then walk away or shamble away, in which case you are now zombie bitten. So on average, when you run into a zombie, there's a good chance you're going to turn into one of those two. And the more zombies there are, the worse your chances are. And everybody has that same chance. So if there's 10 people in an area, each of them has a Z over moving chance of running into a zombie and then getting one of these states. So like in the real world, things can explode exponentially. Now, the reason why exponential growth doesn't result in the entire population being very quickly run over is that, of course, is this immune state, which as more people get sick and recover, the odds of you bumping into somebody who doesn't already have the virus and isn't already immune is lower and lower. So the transmission actually drops off as the virus spreads. So actually it starts off going up exponentially and then it levels off. But with zombies, unfortunately, since you don't get to be immune, and so that will naturally follow these formulas. And if you draw the graph of people over time, you'll see that sort of exponential up and then sort of logarithmic leveling off kind of curve. But with zombies, that's not so good because the zombies just keep eating you. And since they kill the people, they won't run into those again. And the zombie bitten people pretty quickly turn into zombies. And the zombies can smell. They only get their probability of your probability of avoiding a zombie is based on the number of moving people. Remember, zombies are not included in that group. So zombies are really nasty in terms of spreading. Although they kill their own hosts a lot of the time, the flu doesn't do that. So it's not actually obvious if they're still your biggest threat. Because a virus that's extremely deadly is not a very worrisome virus because it kills its host too quickly. Anyway, there's a chance that people fight back. So there's a chance that a zombie will become dead. And that is the number of active people. People don't like zombies. Every person in the area has a 1% chance every turn of killing every zombie, or of killing each of the zombies. You can imagine giving them all sawed-off shotguns or baseball bats or chainsaws, the preferred zombie killing mechanisms, and that would be something that would maybe raise this probability. There's also a chance that zombies just rot because they are zombies, and they just 10% of them die every turn. And also the dead can rise again as zombies. So if you're dead and not dead ashen, that is to say you have not yet been buried properly, then you can rise as a zombie with a 10% chance. You know, with a parasitic zombie, I would drop this off to 0 because you have to have a parasite in you to be a parasitic zombie. With a necromantic zombie, I would raise this to maybe even close to 100% and model those different threats. Okay, so those are the default transitions. If you don't do anything, this is how society progresses. And I will pause to look at chats. Joel, can you help me figure out where the last cutoff was?
I think we're good. I've been trying to keep up with them.
All right, because I've lost track of where.
Yep. So I think we're
into the thing.
I think we're
Right.
up to date. So if anyone had a question that didn't get answered, you need to retype it in because I'm not looking at it.
Okay, so I know this is a pretty common seared model. This is the kind of thing you do in any respectable modeling exercise. And you do more or less detail with more or less contact tracing, more or less subpopulations. You know, the big question is this population of you have an equal chance of bumping into every person really good? Because once a week I go to the grocery store and then I bump into people who are far away from me in other neighborhoods. But most of the time I don't go out and meet my neighbors at all because I sit inside playing computer games and board games. And this is much lower. So maybe this is not a good model of modern society. Maybe this is a better model of society 200 years ago. You can debate that and you can adjust the model if you think this is wrong. I will tell you that even though I'm sure it is a bit wrong, it does a pretty good job about producing pretty good predictive results. And ultimately that's what's important about a model. But the more you can get the subtleties right, the more likely that a surprising result is a real result and not a quirk of some modeling assumption catching up with you. All right. Whoops, I went to send that long sequence of notes to everybody. Not all right. Here we go. That's me putting a line in the comments so that I can tell what's new and what's old. All right, so now let's look at the locations in the board. There are 9 city locations, which are arranged without diagonals. So it's really this graph structure. Now graphs really are not, don't think of graphs as having an XY location, they just have adjacency. So this graph in the middle right is the same as this graph on the left because the adjacencies are the same. In fact, it's the same as this data structure on the right. All that you need to know a graph structure, in this case graph confusingly does not mean anything to do with graphing a function. It is a set of nodes and a set of links, or really a set of nodes and their adjacency relations. So A is adjacent to B and D, and that is all you need to know about A to make reasons about A. If something is going to leave A, it has to navigate this and moves at speed 1, it will go to either B or D. If it moves at speed 2, it will go to B or D, and possibly to a thing that is next to B or D, which is ACE and AEG. And so I can sort of do transitive closure. I can sort of ask, what can I get to from 2 steps by just looking at this data structure, which is what a whole class of graph algorithms are. It turns out to be, there's a very simple data structure. It's immensely powerful and useful in all sorts of things that don't even look like graphs in the real world. Like a city is obviously a graph of location nodes, and you can change the topology. Right now, the game, this is hard coded, but you can easily imagine changing asking for cities that have different, more or less connectivity and are bigger or smaller, more sparse or more dense. Does your policy change? This model will help you answer those kinds of questions. But there's stuff about much more abstract stuff you can do with graphs where, well, I won't go into that now, but it's a very powerful structure. There's whole courses you could take on graph algorithms and how to do them efficiently.
Rob, can I add something before we
Yeah,
get to the next
go
slide?
for it.
So you'll notice in the game that while everything Rob said is true, we have labeled them in a way that sort of make it feel like it's more on the left than it is to the graph on the right. We've labeled them by north, south, east, west directions. So C would be northeast, A is northwest, G is southwest, E is center.
Yeah.
So first of all, they are labeled as though it is the photo on the left. But abstractly, Rob's, you could change those labels and make them whatever you want, and then it's the graph on the right. Also, the adjacencies right now are hard-coded in. So there's not an actual graph data structure or anything. It's simply a list of all the neighborhoods, and then each neighborhood has a list of neighborhoods that it's adjacent to.
And then this is an undirected graph, which means if A is next to B, B is next to A, and there's no sense of there's no sense of direction between them. If you do other graphs, like if A is B's parent, you want an arrow because it matters the relation between A and B, which one is the parent. But when A is adjacent to B, it does not matter. That's symmetric, and so there's an undirected graph. Those algorithms are working directed graphs versus undirected graphs. There's also weighted graphs versus unweighted graphs, which is these edges are all equal. If you're next to B, you are equally next to D. There's no notion of distance or cost. There is a whole class of algorithms where you add a distance or a cost or some kind of weighting on the edge. There could be the difficulty of crossing the edge, whatever that means. And then that affects, shortest path, where you cross the fewest total cost of stuff to get from one point to another. It would be a shortest path algorithm, which is a basic but very useful graph algorithm. This is an undirected, unweighted graph, which is still an immensely powerful structure and super simple. Now, let's talk about how people move around this. How do they use the adjacency? So I mentioned before that I moved away from the probabilistic model and moved towards a discrete simulation model. So I model every individual person as a discrete entity rather than the population as a continuous quantity. You're not just numbers to me. You're little labels in a computer labeled with numbers. Well, here's the model. I can talk about why I think this is good. This is the model I settled on that was very easy to modify later. So everybody has a motivation bag, which is how they intrinsically would like to move around. Green means you would like to move north. Black means you would like to move south. Blue means you would like to move east. Yellow means you'd like to move west. Red means you'd like to stay where you are. And everybody starts with this bag. 60% of the time you stay where you are. 40% of the time you leave in one of the compass directions. No diagonals. If you try to leave in a direction where there is no location, you just stay still. So if you draw a green cube and you're on the top of the city, it's like you drew a red cube. You don't redraw or anything like that. You just don't move. And there's also some of the stuff we'll add, could also add other rules like that. If you try to run into a fence, then you would draw a green cube, run into a fence and say, nope, can't move that way. I guess I'm not moving. I just stare longingly across the fence at greener pastures or possibly more zombies, depending on why the fence is there. And so every turn, you draw a cube out of somebody's bag and you move them according to that direction if you can. This is a random draw with replacement. For those who know some probability, you put the cube back in when you're done. The fact that I moved north once doesn't change my probability of moving north next turn. So this could be very easily just written as 10%, 10%, 10%, 10%, 60% if I didn't ever want to modify it. But I want to modify it by things like, you smell meat to the north, or there's a public announcement to the north saying, this is a safe haven from zombies, which you should always, always trust. That's what I've learned from the movies. The safe haven from zombies are always totally safe. They're not festering mobs of zombieism. You therefore have a higher motivation to go north. So that building might say, everyone to the south of me should add a bunch of green cubes to their bag. So they're more likely to move north. If there's several of these conflicting, like if you're in the middle and there's an evacuation point to the north and an evacuation point to the south, well, the one to the north will add a bunch of green cubes, the one to the south will add a bunch of black cubes. I don't have to come up with a special corner case that says, what if it adds, what if it adds 100 green cubes and 100 black cubes, almost guaranteeing that it will come in. Only the two of you are fighting over which way you go. Now it'll work out to be roughly 50%, like 49% north, 49% south, 1% something else. So it's very easy just to add stuff to the cubes and not worry about who else has modified the cubes and still have everything work out as a nice clean formalism. Which is not true of the aggregate transition model, although boy is that computationally cleaner, computationally faster, but this is formally cleaner. And as a general rule of thumb in algorithm design, start with the cleanest thing and optimize when things are slow. Don't optimize before you know if it's a problem. So I waited for Joel to complain that this was not a good idea before I changed it. And he never complained, so I didn't change it. That's the complaint-based software engineering. Questions? What is the parallel from killing zombies to the flu? Yeah, so right now, if we look at the state transition, there's natural ways that zombies die. They sometimes just rot away. They collapse on their own feet. And sometimes if you have the flu, you get pneumonia and you die. Those are the analogies. There is no analogy to fighting back because people don't go around stabbing people with the flu, but they do go around stabbing zombies. Now, when you add a building that is going to, or some kind of intervention that's going to change this, you could easily add a purge the sickly building that kills everybody who looks sick, including flu-bitten and, flu infectious and zombie-bitten. And that would be an indiscriminate response that's probably overly harsh and going to be bad for your score, but the model should tell you that. Maybe zombies are extreme enough that it's time to have that kind of extremism, and maybe that's still foolish and excessive. So yes, the equivalent of killing zombies is murdering everyone with symptoms. All right. Okay, so it's worth saying exactly what is the turn structure. This is one of the first things I do when I sit down to formalize a game. There's a bunch of things you do on your turn, and usually it doesn't matter, and so you don't think about the order they happen in, but boy, does it matter sometimes. So the first thing that happens is you update the status of the board, modified by the current fear. This is relevant. If you raise fear in a turn, it doesn't hurt the information you got that turn. Then the player chooses their actions. In this case, they build two things. After they've selected both of them, they are placed down. This means that if a placement effect changes part of the state of the world, that state of the world isn't there in time for the other building to get placed. So this doesn't matter. These are simultaneously being placed and then simultaneously resolving their creation side effects. Then we do a transition. Now it matters that the transition is happening after the building. I get a chance to build the buildings and then nature does its course, rather than the other way around, which would be a slightly more reactive rather than proactive model. First, we update your resources. So this is, once again, this order is subtly important. If you gain resources, you do that before you are expected to lose them. So you adjust your resources first and you adjust your fear first. So it's possible that one of these state transitions, in fact, I think it, no, I actually in the past have had state transitions that are proportional to fear. I think that might be in one of the buildings, like a self-care clinic is less effective the more people are scared of going to the clinic. So that fear is being referenced by one of the transitions. So it matters if you raise fear and then check the transition, or check the transition and then raise fear. So to be clear, you raise fear, then you do all the artificial transitions, that is things that are not existent in society but added by a building. Then you execute all of the natural societies in the order I showed before, this order. And then you're done with adjudication. Then after all of that, after each neighborhood has festered and stewed on its own, then people update their motivations based on either what you built or anything else that's happened as a transition of stuff you've already built. So a building might say, add 10 cubes to everyone else's bag, or everyone in this area gets a bunch of 10 red cubes. They're more likely to stay here because I built a fence around you maybe, or something like that. Or I've told you, please don't leave. So those gets updated as a result of this. And then we adjudicate the move. We draw a cube out of everybody's bag and then move them accordingly. Then we see if the game is over, and if it's not, we do this again. We update the board and we do this again, and that's every turn. And then there's on the left is the much longer version that was in my design document. And this is the highlights that are probably most important here. This includes some of the formalism, like the fact that your motivation bag resets every turn. You don't get progressively more and more desirous to go south because there's a building to the south that says, please come south. It gives you a constant motivation to follow at each turn. Yeah, this is all in code, but this is so you have an idea of what you're looking at in the code. There's different debates about documented code. Everyone agrees. Well, there's the theory that you should document your code well, and there's a theory that good code should be its own documentation. And most software engineers I know believe in both. You should write documentation, and the code should be readable even without the documentation. So we'll see if Joel has done either of those things. But I think that he has done at least one. In the sense that if you look at the code, a lot of this will fall out. If you know that you're looking for how do things get adjudicated and you find the line of code, it'll be clear. Oh, I see how he is adjudicating coughs. There's a little line of code. I showed you earlier. You know, there's a little line of like, here is him defining the transitions and default parameters of all these things. And once you sort of understand the basic shape of the game, this code is actually pretty easy to read. Even I, who am not a Python programmer, can pretty well understand what this is and probably modify it, even though I couldn't have written it myself. Sorry, Joel, you were saying something about me making fun of you.
No, I was just going to say there's not a lot of comments in the code because Python is just a super readable language. And so I would assume that some of the comments you mentioned were maybe from like 5 or 10 years ago when languages weren't as readable. So all of the variable names are all very readable variable names, like I died using Z or K or whatever. So they're all meaningful variable names. The functions are all well-named descriptive function names. And the code is hopefully very readable, even though there's not a lot of comments.
Okay, so that's how a turn is executed, which then puts all that earlier stuff in context. Let's look at the interventions. So in the current version, through my various additions and removals, I settled on one kind of intervention, which is building the building, which then permanently modifies the transitions in that location and possibly updates resources. Its own global effect is adjusting resources or fear, which affect the entire city. Everything else is a local effect on that location or the links into that location. This is a thing that you could easily extend, but do it with good intention because it's something you want to study, not just because it's a thing that happens in the world and it would be fun. But it would be fun. Maybe do it because it's fun. But then be ready to rip it out if you decide it's not helpful. That's why I highly recommend the addition subtraction alternation. I like to emphasize that. Don't try to come up with the perfect game. Don't try to start with a superset of the game and pare it down. Don't try to start with a subset of the game and build it up. Go back and forth. I started off with the game being almost entirely about a response team moving around in the city and taking actions. And then I added this notion of leaving buildings behind. And then I added the notion of building buildings not at your location. And then I realized this team was not actually an important part of the game anymore. It was not a dominant part of the strategy. It was kind of a detail that was just adding a whole lot of rules. So I took it out entirely. There's no response team anymore. There's just buildings that you build. And I found that when I took that out, I didn't lose any of the technological analyses I wanted to look at, or really any of the strategic richness about the paths to victory that I wanted. And so while it was realistic to have a specialist team moving around, it wasn't worth the complexity to the player or to us to include it. And so it went. So as I mentioned before, what can a building do? It can create a new transition. And I'll show you a bunch of examples of buildings in a moment. In fact, I'll go through all of them. It can modify an existing transition. So that's why all of these transitions are named. So something can say something like incubate rate times 1.5. And that's nice and composable. If two things modify incubating rate, you know how to resolve it. Because right now we only modify things by multiplication, and multiplication is commutative. Yay, algebra. It can adjust your resources, fear and material. If resources try to go below 0, everything that costs resources on a turnly basis disappears because it wasn't sustained. They can adjust motivations. There's actually a special rule for adjusting movement by blocking movement into your area. A couple of things, essentially build a fence, and they say when somebody tries to enter this area, there's a 95% chance they just don't. And as I said, they can have a one-time accretion. So some buildings give you one fear when you build them, but then people get used to them. Some buildings give you a fear every turn that they exist. All right, let's look at the buildings. Yes, there are buildings that produce resources, and we will get to those.
Rob, I think I have made a mistake. I don't think any of in the software implementation, I think they all, if there's a fear, it's every turn. I don't think I got the.
Oh, you didn't do the creation cost?
Yeah.
Okay.
So
Well,
I think it's just every
that might
turn
be
it
why you-
looks and says certain deployments cost resource, certain cost fear, certain lower resources, certain lower fear. And
well,
so every term I just look at what deployments are there and I bump up or raise, I raise or lower the fear and the resources.
well, it's possible then
programs that are
we
there.
should remove those fear costs so they don't distort the analysis too much, or that's an exercise for the studious student.
Yep. So just pointing it out, that was something that got lost
Yep.
between the design
Worth be
and the
aware so you're not-
implementation.
Yeah.
And it happens all the time. Those are the hardest bugs to catch.
Yeah.
Because
Okay,
they
so questions.
yeah.
Right now, zombies do not break into buildings. I considered that at one point, that zombies might overrun the stuff you build. But ultimately, I figured if you're deploying resources to a city, those resources will be secured against zombies if you know that there are zombies. The question is how and maybe that's not a fair assumption, but I think it's a fair simplifying assumption. If we're not testing the security of our response, we're just testing the effectiveness of our response. I think that's, so right now they don't take over buildings. All right, so let's look at the buildings. There are 12 buildings. Well, really, there's 24 buildings. I've lumped them logically into 12 buildings, each with a nice and severe version of them. Now, in the spec, a thing that we decided to not put into the code when we were going through, because it turned out to be more complicated than I thought, was the ability to toggle buildings after they were built. There used to be an option that says every turn you could also pick one type of building and toggle all of those buildings to the other type. So you could build a bunch of don't panic emergency broadcast buildings, and then on one turn, pivot them all to call to arms and have a whole bunch of people attack the zombies. And then the next turn, pivot them all back. And that adds some interesting dynamic strategies. But it wasn't necessary for a lot of the stuff we wanted to teach. It made things harder to encode for machine learning, more complex in the code. And so in general, it wasn't serving its requirements as well. So we left it out, but it would be a cool thing to add back in. You might notice by now, I don't have a shortage of things that I want you to add back in, which probably means I'm in an expansion mode and somebody should snap me back into a contraction mode at some point. So I'll go through all of these, not so much to tell you, just so that you will remember exactly what they do, but to show you how we encode the special powers, what kinds of special powers can be encoded in the formalism we have, and how those encodings look, so that when you see them, you'll have a sense of what you're looking at. So it's more going to be how you encode stuff than trying to remember exactly how a sniper tower works. Okay. Zombie Cure Station using FDA-approved drugs. It can add a transition that is just like the transitions we saw before. This A means an artificial transition that is being added. Zombie-bitten people can become non-zombies. Note that you're not immune because you can't be immune to zombies. But if you get an FDA-approved drug, you have a 25% chance of being healthy again. And if you have the zombie, you even have a 1% chance of going back to just being bitten. It's such a good drug, it even has a chance of pulling you back from full zombieism. So feel guilty the next time you kill a zombie, because they were savable. However, they cost you a resource every turn. G is for global update. So I've categorized everything in terms of when it triggers to make sure that I was sticking to my formalism. Earlier on, I had buildings like, this overrides the effect of fear on displaying information. But that can't be expressed in this formalism. Information in buildings like that might be interesting to study, but right now they're not expressible. So FDA drugs are expensive. They're experimental drugs, which, well, in my spec, when you create them, people get scared because they heard the FDA is deploying a new drug, but only the turn they create them. But they consume resources to keep distributing them. They are more effective at curing zombie bitten, but they're experimental drugs, and so this is the order in which they trigger in. So there's a 33% chance that you will be cured. If you don't, in the remaining 2/3 chance, half the time you will die. That's how good this experimental drug is. If it doesn't save you, it kills you. Which, if you think about it, might be good for society, but boy, is it not good for you. Because this, and with FDA drugs, if you fail this turn, you can try again next turn. With this drug, if you fail this turn, you're dead. You're not biting anyone, but you don't get another chance. If you somehow survive both of those, there is then a chance that you will regress. And there's a chance, of course, still that you'll stay a zombie. But experimental drugs are very good at turning you into some other state. Now, here's a bite center, which modifies natural rate. So it modifies the turn rate. So if we look back at the turn rate, the turn rule is the chance that a zombie bitten turns into a zombie. So this halves the rate of turning because you clean the wounds and then the infection doesn't spread as fast. You're still zombie bitten, you just didn't turn into a zombie. So maybe a strategy is to spread a whole bunch of bite centers around until you can build up enough resources to then deploy some super cool building that will cure, and by cure I definitely don't mean firebomb, the zombie threat. You can also, amputate, in which case this is one where really it does every turn that you have an amputation bite center in place, everyone gets scared because they see people's limbs getting cut off. But boy, do people not turn when their limbs are being cut off. If you get your limb removed in a medical facility, you don't die. You only have a 5% chance of turning into a zombie. You're still zombie bitten, notice. You just didn't turn into a zombie. So we have to keep taking off limbs. But, life's full of choices. I don't know if this is a good one. We can look at similar buildings for vaccines. The free clinic, once again, here's the cross product. So a free clinic says if you're in any of these states and in any of these states, then you can become immune to the flu without having had to go through. So if you are, unfortunately, the free clinic is 20% chance minus fear to a minimum of 0. So people are scared of you, they don't take the vaccines, like in real society. Mandated flu vaccines get rid of that fear factor. They make people take these vaccines, but when you tell everyone you have to take a vaccine, boy, do they know you're serious, and boy, do they get scared. Also, mandated vaccines are taken by more people, and you consume resources. A kiln burns people faster. A kiln with no questions asked burns people much faster, the dead much faster. And sometimes people lure zombies into kilns because boy, are zombies stupid. But also, sometimes the sickly fall into the kiln, and sometimes the active people fall into the kiln because there are no questions being asked. Part of the tradition of zombie movies is the dubious morality that emerges in zombieism. In fact, in the original Night of the Living Dead, the first era of the modern zombie movie, one of the twists in the 90s shot-for-shot remake is that one of the main characters shoots the unlikable lawyer at the end of the movie and says, I guess he was just another zombie. But you know that she knows he was healthy and she just didn't like him, and she gets away with murder. No questions asked, kilns are dangerous. There's emergency broadcast, which lowers people's fear every turn if you tell them not to panic, or you can tell them to panic in a useful way. You don't lower fear, but people fight back better. But when you fight back, you also get killed faster. So you're more likely to get killed fighting zombies, and you're much more likely to kill zombies. And the moment you're told to fight zombies, people say, whoa, I was supposed to fight a zombie, and then you get used to it, because that's how zombies work. Sniper towers can, as a tradition, they can kill zombies. So a zombie has a chance for every zombie in the area to become dead, but that chance is 1 over the number of zombies. So if you do the math, if there's 10 zombies, each of them has a 1 in 10 chance of being killed, which means on average, you kill 1 zombie each turn. This is the roundabout way of making it to kill 1 zombie each turn. My formalism doesn't allow me to express absolute numbers, only percentages and multipliers. Or you get into formalism problems, like what if I have 3 sniper towers who kill 3 zombies, but there's only 2 zombies? I mean, that's not hard for us to imagine what should happen, but it's not, the computer doesn't know what to do. So this is a nice formalism, fits in this nice clean version. Everything is just a probability of a transition. Open season, you're much more likely to kill a zombie. Well, you're more likely, you're likely, you shoot at every zombie, but they might be hidden in the crowd. So it's a different difficulty. Here you're aiming at the zombie and you have to wait to hit the head. Here you should anyone who looks like a zombie, which sometimes is somebody who's bitten by a zombie and is somebody who just has the flu. Somebody asked about this earlier. I was way ahead of you. Yes, open season sniper towers are not necessarily a kind of a thing I would recommend in civilized society, and that's why they make people scared. But maybe they're necessary in a zombie outbreak, and that's what the mayor wants to know. A BSL-4 lab is how you get resources. If you have at least 5 active people in an area, that is people who are active members of society, they generate a resource. If you don't, they don't do anything. But you can turn off the safety protocols, and then they go on automatic, and they generate 2 resources every turn, even if you have no active people. But they have side effects. The dead rise from the dead more often in the area, and the dead bodies are more likely to give people flu in the area. These are the 2 things that make people worse proportional to the number of dead in the area. So either you want to do this somewhere where there aren't any dead bodies, you want to put a kiln with it, or maybe dead bodies aren't a big deal and you just accept this cost. I assume they're like, I don't know, they're testing on dead animals and throwing the animals outside or something, or piling them up in their lab and letting them rot and then running experiments in the public or something. You know, the nice things that happen in zombie movies. Then here's the famed firebomb. Now, this is a relic of the idea of being able to toggle a firebomb. The idea was you would deploy it in a primed mode. And when people see a primed firebomb, they get scared every turn. And then eventually you toggle all the firebombs, and then you get barrage. And then while they're in barrage mode, every turn, well, when you first go into barrage, people get really scared because you just fired on a civilian city. But every turn, half the dead get incinerated. All of the moving die. So 10% of the moving die, and 90% of the moving who survive dying die and become ash. A tiny fraction will survive and not die, but pretty much you wipe the area clean, mostly to an ashen wasteland, which is also known as sterile. And it costs resources. But in the old version, you could then switch it back to being primed, but you could never get rid of it. Once you committed to firebombs, the population was going to be scared of you forever, either because you're bombing them or because they know you're likely to bomb them. In the current version, it's now pretty pointless to build a primed firebomb because all it will do is raise fear. But that is not a bad litmus test or baseline test. Hopefully the AI will pretty quickly learn to never build primed firebombs. There's still a question of, do I build barrages? I just can't do the sudden surprise twist, but you can still stay, well, you know what, there's enough zombies in this area. I'm just bombing it because all those people are dead anyway. I'm not sanctioning killing everyone in the zombies together. I'm just saying I'm a scientist and I'm willing to keep my mind open to the possibility. There's, of course, social distancing, which lowers transmission rates of flu and bites and fight back. Because if you don't bump into people, they don't cough on you, you don't inhale dead bodies, you don't get bitten by zombies, and you don't smash zombies. Also, when you tell people to socially distance, they're less likely to leave the area. You add 2 stay cubes to every bag in the area. And people who try to enter the area, let's see, sickly and active people stay. Zombies, of course, don't pay attention to the signs. Zombies don't read. And sickly and active people who would leave have a chance to stay. On top of wanting to stay, they have a chance to just not leave. So even if someone else is saying, please come south, the signage says, oh, wait, 25% of you will agree to just not, you'll follow the honor system rules and just not leave. You can do a celebrity endorsement of social distancing, in which case you're a little scared at first. You have better rates because everyone listens to celebrities, but you have to pay the celebrities, so it has an upkeep cost. They're much more likely to listen to celebrities, so 9 cubes are added to every bag. So if you do the math, yeah, you get some math. Oh, these are the base rates. These are the base rates that are being modified here, so you get a sense of how good a celebrity endorsement is.
Hey, Rob.
Yeah.
I just want to note that all of these probabilities are all clamped from 0 to 1. So obviously multiplying a probability by 25% is not an issue. But some of the other ones moving forward, they're multiplied by like 5 or 10.
Oh, yeah.
So just to make a note, they're all clamped and checked so that they're never not between 0.
Yeah, good point. Whereas resources and fear can't go below 0, but they can go arbitrarily high. Or there's some really high limit Joel put in the code to manage the state, which is higher than they should ever get in any reasonable play. There's a quarantine facility, which is focused on moving. The open quarantine, if you're healthy, you're likely to leave. If you're sick and next to it, you're likely to enter. And this is the result. I'm doing the math. Here's your default. And when you, if you're in the middle of the map, so all directions are possible, and you put an open quarantine, here's how the probabilities shift. You can get a sense of what the effect of these are. I'm just doing the math to check that that adding 3 cubes is relevant and adding 10 cubes is relevant. So this is a quarantine of bad people, not a quarantine of healthy people. You can do either one. This is the pull the sick people in, push the healthy people out, and try to keep them away from each other. There's also a fence quarantine, which is exactly like quarantine, except it scares people and it stops people from actually moving. Instead of just encouraging them to move, it stops them from entering. You can actually sneak out of the fence, but it's very hard to sneak in the fence. A rally point is another way of controlling movement. You pull everybody into the area, or if it's evacuation mode, you pull everyone out of the bag. You push everyone out of the region by adding north, south, east, west to the bag. Pheromones, you can make pheromones smell like brains, which mostly just smell good to zombies. So zombies are very likely to enter an area with pheromones. Zombie bitten are starting to take on a taste of brains. They're slightly more likely to enter. If you make it smell like meat, zombies also like meat because where there's meat, there's brains. The bitten really like meat because where there's meat, there are people to bite, and that's what a zombie bitten wants to do, is find a crowd. What the virus in them wants to do is have them find a crowd and then turn into a zombie in the middle of the crowd. And also, everybody likes the smell of meat slightly. But it only takes a little bit of brains to make the smell. It takes a lot of meat to make the smell of meat, so you have to spend a lot of resources on this. And also meat calms people down. Meat technology. The mayor wants to know if they should invest in meat. Okay, so that's how it works. As a reminder of some of this, these are some of our initial conditions right now, but that's configurable. The economy by its default supports, you start with 10 resources and you can gain a little bit each turn. So you don't necessarily have to build a BSL-4 lab just because you want to use resources. We only allow, every transition I've classified in the spec as one of these categories, which really just tells Joel as the implementer where in the code it falls or where it gets referenced. Is it a modifier on a baseline? Is it a new rule that needs to be adjudicated? And if so, here is the order they are adjudicated in. I have to spell that out. Zombie cure stations trigger before sniper towers. I decided to do the optimistic version where you try to cure people and then you shoot them in the brain rather than the reverse. I don't think it's a big deal, but it's the kind of thing you have to formalize. So these are all of the buildings that add artificial transitions. So I had to rank them all. And then I talked about some of this will go along the way, but as a sanity check, is that one check, is this more complicated than we need, and the other check is this complicated enough to be rich enough? And both of them are based on, does it create the kinds of dilemmas that we want to study? So the dilemmas about which threat we prioritize. Well, you have stuff that treats zombies, stuff that treats flu, and stuff that kind of affects both. How harshly should you respond? Do you want to lower fear and get information and then react dynamically, or do you want to ignore fear and react broadly? And is there a strategy that is possible because of one of these buildings that wouldn't be possible without them, or are the strategies that are possible with these buildings just not as good if you don't have all of them? Now, there's a bunch of stuff that we did that emerges from this. So one is fog. So in military terms, fog refers to not knowing what is present on the battlefield. So here, fog is the fact that you don't have perfect information about the state of the world. I think it's extremely important to add fog into games. It's one of the most common things to leave out of a model that I think is really a problem. It's much more of a problem than not getting the parameters quite right in your transition model, because the real world does not have perfect information. And a strategy and a technology that relies on perfect information is not a strategy or technology that works in the real world. Now, you can adjust the level of fog and you can look at its effect, and you can decide how much is it worth paying to reduce it versus just ignoring it and doing your best. But you certainly shouldn't fail to model it. There's also sort of non-linear effects emergently, which is there are combos. Like if I build a BSL-4 lab and a kiln, it's really good together, better than either of them is by themselves. But then I had to commit a bigger investment. So hopefully the AI will discover these things. Hopefully the players will discover them. There's, you know, the movement between areas makes me think like I can put a quarantine, or I can put an evacuation notice in one area and a sniper tower cleverly placed to try to catch the zombies. And then maybe I can put the sniper tower into open season mode. But I pulled all the healthy people away, so the collateral damage is manageable. So things that are a terrible idea by themselves might be a good idea together, or spatially arranged on the map. There's certainly a question of shifting over time. Do you build a bunch of BSL-4 labs and then respond with all those resources? Especially if you add back in the toggling mode. But even without that, there's some temporal stuff. So there's a bunch of these things, and we haven't modeled initial conditions, but it's an obvious thing to do. Is if I vary the severity of the initial zombie outbreak, does that just make my scores lower, or does it actually change what my best strategies are? The general question we ask with these kinds of technologies. And usually if you're doing more basic research, you're looking for technologies that fundamentally change what can be done. So something that just makes people a little bit more efficient is not a ground-breaking disruptive technology. Things that make people able to do a strategy that just wasn't feasible before are the exciting ones. But if you're more if you're more pragmatically focused on the shorter term, you might be looking for something that could be deployed right now with no change to doctrine. You don't care if it enables some crazy weird strategy. I don't have time to socialize that. I want something that works now, and that's a very different analysis. And that's the kind of thing you have to know when you're formulating your program about which of those is what you're aiming for. That's what I've got. Let's see. Yeah, so
You didn't mention it in the talk, Rob, but I put it in the chat to see if people knew where you got the word fog from.
oh yeah, I was about to go on a tangent about that. Well, actually, I don't know where it came from. I know where it is popularly cited.
Oh, that's a good.
I actually don't know origin. So usually people cite Clausewitz, a Prussian military theorist who said a bunch of stuff about military strategy that proved to be pretty universal advice, and he's still read today in military academies, even though he was writing about World War I or something era technology. When was he? Was it pre-World War I? Was it Civil War era?
I think it was pre-World War I. My history is not that.
I don't know. It was pretty early. But one of the things he talked about is the difference between real war and ideal war. And ideal war is what you study and theorize about, and real war is what happens when nations clash each other and a bunch of people die and civilizations fall.
It was in the 1800s, so
more Civil War era, Napoleonic era.
Yeah.
All right. Muskets. But people still study it in terms of tanks and airplanes, which he didn't have. But he said, but real war is characterized by three things that people forget, which is fog, friction, and chance. Fog is you can't see everything. Friction is when you tell somebody to do something, they don't always do it. And chance is even if you see something and tell someone to do something, they try to do it, things don't always work the way you want. And if you're going to study war, you have to think about those three factors. And this is true about really other domains, especially emergency response. If you don't think about fog, friction, and chance, your analysis is not credible. Or your analysis is very specialized, and you better be very clear about that assumption and what it's limited to. You'll often find cases where if you have no fog or friction, one strategy is optimal. But if you add even a little bit of fog and friction, that strategy becomes completely untenable. And a thing that used to be only so-so is robust against the fog and the friction. But the previously optimal one is completely brittle and falls apart when the conditions aren't perfect. And so often in the real world, you're looking for the 80% solution that only drops to 75% in fog and friction, rather than the 90% solution that drops to 5% in fog and friction. And so if you want to study the whole system, you have to think about what is a realistic amount of fog, friction, and chance. Now, fog, friction, and chance, of course, also add noise to your experiment, but that's life. Oh, yeah, people talk about League of Legends, Alex M. Yeah, so in League of Legends, a 5 versus 5 MOBA with Fog of War, standard Fog of War, which is you can only see things that are within the view radius of where one of the people currently is. There are sight runes or something you can put down that give you vision for a short period of time in a short radius. And new players scoff at these, and intermediate players scoff at these, because why would you spend money on that when I could be buying a cool sword or a health potion that'll save my life? The expert players always buy them, and if you look at their eye movements, spend a lot of time glancing at the map where they put them. The experts in League of Legends know that removing the fog is one of the most important things you can do in that particular game. And you can imagine how League would be a much less interesting game if there just was no fog at all. Everyone always knew everyone was. There'd be no ambushes. There'd be no maneuvering to outnumber somebody. There'd be no, judgment calls about, trying to second guess what the enemy strategy is. Yeah. There are other questions I've missed.
I don't think there are questions that we missed in the chat.
Yeah.
I think we have question and answer session, and we roll into office hours at 4, which we can switch over to the Discord for. So I know
Sure.
we've been going for a while, so
Yeah, we should take a break. Sorry, that ran a little longer.
Yeah.
I sort of lost track of it.
why don't we take a break? And if there are any further questions questions, we can answer them during the office hours at 4. So we'll break and we'll see you all Discord if you want for office hours at 4. Does that work? Chris and Rob, does that work?
That works for me.
Sounds good.
All right.
Joel, will I be part of the office hours today, or will that be tomorrow?
Part of the office hours. Oh, so it's on the schedule. It's me.